Okay, so we were discussing about plotting a data frame. Already we know data frame is made up of tabular representation, that is rows and column. So when you are trying to plot a data frame, each column, that is each series, will be treated as one line graph or one bar. If you are drawing a bar graph, then for each column there will be a separate bar. Okay, or for each column there will be a separate line. Okay, so if it is made up of three columns, okay, so for one column whatever values are there, there will be a separate line plotting. For second column again there will be a separate line. For third column there will be a separate line. Getting? Or if you are drawing a bar, then for one column there will be a separate bar for each value. Getting? For each value there will be one bar. Okay. Along with that, for second column, each value there will be a separate bar. And for third column, again for each value, there will be a separate bar. Okay, so that thing you should remember, right? So a data frame represents a table. That is its originality. Every data frame represents a series, multiple series. So each series is one column. So when you plot a data frame, Pandas will automatically plot each column as a separate line or a bar. Okay. And creates a handy legend means your labels are there. It creates a color for each that are called as legend. Like when we were taught graph in school days. So there we used to write, no, this color represents this. So in the legend, it will tell like this color is for store one, this color is for store two. Okay. So there is a small label in that graph, in that whole graph. At the top, it will show a legend telling which color represents what. Like, okay, like if there is a red color for store one, red color store two, green color, blue color for store three. So it will tell that. From here, we can then interpret that whatever red line is coming is for store one. Green line is coming, that is for store two. Blue line is coming, that is for store three, like that. Okay. We will take an example of plotting a data frame, but a line plot I'm doing. So multi-line plot for comparing trends. Like you have some products, some five products you are selling, but in three different stores. Store one, store two, store three. Getting? You have three stores, and in three stores you are selling the same product. Best example you can take, like in Pune we have Chitade. So they have so many outlets in Chitade. So they want to keep, and their products everywhere are same. So each product in each outlet, how much is getting sold, and then they want to find out the trend on it. So the store will become the column label. Your store one, store two, and store three. Getting? And here, whatever values are kept, that are the sale done in that store, sale done in second store, sale done in third store. And the row label you can give as your products, whatever products are there. Like you are selling only five products: A product, B product, C product, D product, E product. Getting? So these five products, their sale is kept. 3 sale, 8 sale, 9 sale, like that. Now, when you're plotting a graph of this data frame, okay, as a line graph, then for one series, there will be a separate line. Getting? And these row labels will act as the X tick. On X tick, what will be there? The row label A, B, C, like that. These row label act as X tick label. And Y label will be the values. What values are there? 3, 8, 9. So it will be 1, 2, 3, like that. So A is 3. Somewhere 3 is coming here. Okay. Then B is 8. So 8 may be somewhere here, 9 somewhere here. So this becomes one line for store 1. Then similarly, store 2. So for store 2 also, there will be some different line. Okay. Same way, there will be a separate line for store 3. Getting? And for all three, the colors will be different. That in the legend, it will show. In the legend means there will be a small box, and in that they will be telling which color represents what. Getting? So for each column, there will be a separate line graph. So next column, second line graph, and for third column, third line graph. Okay. So these X ticks will indicate the row label, and these are the stores. And for each store, there will be a separate line. Understanding? Clear? See here. So we are taking, for example, here I'm showing only for two stores, store A and store B. So first we have created a data frame, which is a dictionary. Okay, first we are creating a Python dictionary, and then we are going to create a data frame from that dictionary. Okay, so dictionary, key and the value, key and the value. Key is the store name, and value is the list for 4 months sale. Again, next store, 4 months sale. Okay, I hope this part is clear. If you want, you can take one more store. Then months, I'm going to use as a row label. These will act as a row label. And then from this data, which is a dictionary, I'm creating a data frame, pd.data frame. I'm passing that dictionary, and then I'm giving this list of labels to index. Whatever list you give to index, they will act as a row label. So your data frame will be like this. Here you will have Jan, Feb, okay, March, April. This will be the row label, guys. And column label will be store A and store B. Automatic. In this dictionary, this is your key. So that becomes automatic column label A and B. And here that values are there 10,000, 15,000, 13,000, 18,000. Again, 12,000, 11,000, 14,000, 19,000. This is your dictionary. Now this dictionary you are giving it for plotting. Okay, so df.plot, then the graph is line graph, then the marker what you want at each point like S, and approximate dimension you have given for your graph. Scale you have given 8 by 4. 8 block horizontal and 4 block vertical. Title you have given for the whole graph. So whatever graph will come, the title is monthly sales comparison. What will be the x-axis label? Months. Y-axis revenue. Okay? And remember, these months, January, February, March, April, they will be on the X tick. X tick, what will be the label? These months. And on Y tick, the sale. Okay? And if you want to show that grid, make grid equal to true. And then call plt.show, which we are using from matplotlib. Okay, so plt.show will actually draw the graph on the screen, right? So we can draw this. See here. First, import pandas as PD I'm giving, and then import matplotlib pyplot as plt. First, I'll just create my data, which is a dictionary. Okay, so first I'll give my first store, store A, and the sale. Okay, I'm keeping it for 4 months. Okay, 4 months. So 1100, 1500, then 700 only, 1300. ठीक है. Then we will go for second store, right? 1200, here 1600, then here 900, then 1200. Suppose I'm having store C also, third store. ठीक है. Here 1000, 1100, here 1000, here it is 1000 only, or we'll take something else. Suppose 1500, 15,000 it is. Okay, so this data is done. Then labels, if you want, row label. Okay, so I'll give that as months equal to and month. Like first I'm taking Jan, Feb. Okay, so this is the sale of 4 months of my different store. So store A in Jan this much sale, February this much, March this much, April this much. Same way, store B for 4 months, store C for 4 months. ठीक है? March and last is April, suppose. Now we are creating a data frame for this. We'll call name to it as data frame sales. PD dot data frame. And then I'm passing that that data. And if you want, you can just check this data frame now. Automatic, the row labels will be 0, 1, 2, not this. Okay. Okay. I did print it. Actually, we were supposed to print as well. You can print and see this data frame sales. It is connecting. Done. Okay. Now, can you see when you print this data frame from this dictionary, the key have become the column label, right? And row label I didn't pass, therefore automatic row labels are 0, 1, 2. But suppose I pass that row labels also, comma, index equal to months. I pass that months array. This months array, if I array means list to this index attribute, then it will use this Jan, Feb, March, April over here, row label. Can you see? Now this I'm going to use it for plotting. Okay. So for plotting purpose, I have to use, I don't want to print that data frame now. I just want to plot it. So I'll write df sales dot plot, then give what type of graph you want. Kind equal to line graph. Then marker if you want to give. Equal to, right? See here, marker. Figure size you can give. Marker equal to, suppose you want circle, that is O. Then fixed size you can give a tuple 8,4. Okay? Then you can set the labels and title and all. So plt dot title. See here. Pass the title. So title up to you. What you want the title as. Monthly sales comparison. Okay. Then X label if you want to give X label. Like X label will be months. plt dot y label you can give. Y label, if you want, give as revenue in dollar. Okay. Then the grid is to be made visible or no. So true if I pass, that grid will be visible. And now finally we have to show it. So I'll write plt dot show. Okay. See. Can you see the graph? Can you see this legend? This is called as legend. It is telling which color is used for which store. Okay. So can you see the X ticks are that row label and the Y ticks are your actual values in that column. Whatever value is there in the column, that is Y tick. Then X label you have given months, Y label you have given revenue, graph label you have given this, grid true, therefore that cells are seen. Okay, approximate 8 by 4 it has taken, approximate. Okay, and accordingly the plotting is done. See, for the first series 1100, 1500, getting on no? Store A. Store A is blue. So here it is 1100, then 1500, then it was 700, and then 1300. Getting? So from that graph, you can see that how these two are doing. They are doing very well. But end here, this has come down and this has gone up. Means this store is doing better and that store has done less in April. Getting? And the green store C has done very well. Means store C was doing not that great initially. Okay. But after March and April, it has started doing very good performance and it has gone beyond this both the store. Means the sale of store C in March and April has shown good performance than the other two stores. Getting? So this way you can plot line graph. Multi-line graph. Okay. See the output. As we took only two stores, so here we are getting. In this graph also, can you see that store B after March and April, it is doing more better performance than store A. It has gone ahead of store A in both the month. So this way the analysis is done. Okay. So Pandas generate two lines, one for store A and one for store B, and automatically generates a legend in the corner. Can you see here? It is telling which color it has used for which store. So like blue is for store A and orange is for store B. Okay. And automatically generates the legend in the corner with the column name. Getting? So I hope you got this. Same way you can draw a graph also, sorry, a bar graph also for data frame. For data frame, we can draw graph. So in that case, what will happen? X label and Y label. When X ticks will be that month only. April, sorry, January, February, like that. Okay. And for store A, for each month, a bar is drawn. Suppose here one bar is drawn for January, one bar is drawn for February, another bar is drawn for March. So these are all the bars of store A. Now, besides that only, there will be another bar of store B. So store B, Jan it is doing this, Feb this thing, March something more. Okay. Same way, besides the third bar will be for store C. Getting? So this will be called as a grouped bar. Grouped bar. Right? And there is a stacked bar also. What it does, it shows the other store bar above it. First, it will show the bar of store A. Then above that bar of store B. And above that bar of store C. So you can get the total of all the stores in January. You can get the total of all the stores in February. Getting? So it depends on you what type of bar graph you want to draw, a grouped bar or a stacked bar. Okay, both I'll show you. First part is it is drawing a which bar? Group bar. Means one bar, besides that the second, besides that the third. Means you will have three bars for each month. Jan month, 3 bars will be projected. February, 3 bars, that way. So it will be a comparative study. Comparison there only for month. Getting for Jan month, we'll get one like this, and second besides that only, and the third besides that. So comparative study of 3 stores. In Jan, first store has done this much, second store has done better, third store has not done good. Getting? Same way if we go like this to the last month. So if the bars are shown like this, okay, so comparatively study that second has done better than first, third has done better than second, like that. So comparative study. And if you want the total sale of all the 3 stores for each month, then you can go for that stacked bar. Okay, see here. So when you're plotting that graph, you have to tell the kind is bar. Okay, then width I've given 0.8, so it is according to the scale. Then title, whatever title you want to give, and then show. You want X label, Y label, all you can mention. Okay. And here we are plotting which one? The bar only, but stacked equal to true I am giving. Okay. This is some font and all use. Right? See here. If I take the output. So when you give that parameter stacked equal to true, when you give stack equal to true, then it will be one above another. And when it is false, which is by default, it will be grouped. All the bars are one aside another, like this. It will place store A bar and store B bar next to each other for every month. Getting? So when they are besides each other, the comparative study can be done. And if you want the total of all the 3 bars for Jan, all the 3 bars for Feb, then you can go for stacked. So when you write stacked equal to true, it will pile up all the bars one above another. Getting? So pile store B sales on top of A. So first A sale, above that B, above that C. So with this, we'll be able to get the total sale of all the stores each month, which is perfect for seeing the total combined market size while still seeing the individual contribution. Means each store contribution also and the total sale done by our all the 3 stores. Getting? See here. This type of graph you'll get when it is grouped false. Grouped false nahi, grouped true, stacked false. So if stacked is false, then it is grouped. Right? So can you see for each store 1 bar for each month? Getting? So it is a comparative study there only. Like if you're seeing the store B bar more than, so we can find out store B is doing better than store A in Jan. Getting? In February, store B did less sale. Other both the month, store B has done better than store A. Store B has done better than store A. Okay. And if you go for stacked equal to true, stacked equal to true, then one above another. So total also you get total sale of both the stores, that also you get. And along with that, there only you can see the contribution also. Getting contribution of both. Like total you are getting as around 22. So we find out like 12 is the contribution of B and 10, 100, 10 is the contribution of A. So 10 and 12, 22 you get over here. Getting no? Clear? So this way also is possible. It's up to you. See here, in this only what I'll do is I'll show you. We'll take this data frame only plotting will do different. Okay, df sales dot plot, and I'll give kind as bar. Okay, other things up to you. You want to give that graph size and all those things. Is not mandatory. Then title, if you want to give df sales dot title, df sales dot title name, plt dot, very sorry, plt dot title, whatever title, the same title you can give here, like monthly sales comparison. Okay, then plt dot x label if you want to give, right? X label months, then plt dot y label you can give, y label revenue in dollar, right? Then X label, Y label, and then you can show the graph. Okay. Now in this case, I haven't given stacked equal to true. So it is by default grouped. See, three bars are there for three stores. For three stores, three bars. So store A, store B, store C. So this way, what has happened from March and April, store C has done a better performance comparative to the other two stores. In March, store C has done better than other two. And even in April also, store C has done better performance than other two. Getting? So I hope you got it. And the same if we plot in another cell I put. But while plotting here, we can give that parameter stacked equal to true. So when I give stacked equal to true, it will put this bars one above another. See. So you are getting the total also. The total revenue of Jan, total revenue of Feb, total revenue of March, and total revenue of April. Getting or no? So total study, comparative study, it's up to you. So comparative study, then draw the bar one beside another. Okay? So this way you can plot. This way you are able to plot the data frames as well. Okay? Data frames also you can plot in this way. Now, one example we'll see, that is plotting pie chart for a series.
Sir, I have one doubt. In that
Huh.
bar chart, in the reference line, we can put reference line. Uh, either cross the reference line or below the reference line, like that. So,
The drawing you need to check again. You want that this much should be the target. Which bar you want? The stacked one or
no,
grouped
any
one?
bar, the reference line. Suppose 800, if you put reference line, yeah. So it will cross something. So that's what.
If it is going, if it
Uh,
is less than that only, then it's not doing good performance. If all the three
uh,
stores have gone above that, so you want to just draw that reference line.
yes, yes, yes. Is there
Ah,
any?
yes, it might be possible.
Okay.
Just one horizontal line you want to show.
Yes, yes.
Okay.
Yeah.
Yes, it possible. It might be possible. 1 minute. We'll cross verify. We'll take this. quickly I'll just put it in the chat window. Okay. Now here we don't want that. My machine is going slow. Okay. We don't want to plot this one. Our plotting is this much part. Okay. And we will put this code over here. Okay. Now in this, I want to show a horizontal reference line at 800, suppose. Okay. Can we do? See, you can by using plt.axh line. Just that extra thing you have to add. See, remaining everything is same. Okay, but just you can add that. Here I'll add it of the plot. See, label as target 800. Getting? See, can you see this? So already you have kept some target that all the stores every month should do minimum 1200 sale. Getting? So minimum 1200 sale all should do. So if I keep this reference line here, so for the January month, no one have crossed. But if you come to February, the third store is still not doing, two have gone. Getting? Again, in the third month, all the three stores have come down like that. So we have shown it at 800. You can take Y value, whatever, like 1200 if I take, accordingly it will show. Clear? Can you see? So this both three stores are below the reference line. In that month, all have done the poor performance. Getting? And in next one, the second store is not yet crossing its target. The other two stores have gone. Like that. Okay? So I hope you can do it. Got this? AXH
Okay.
line. Now it depends on the requirement. Na? Like if you are really working in that field, then you get the ideas. Like what is the requirement given to you? Right or no? I'm giving you the basic thing, but if you're actually working in that area and you are being told that in that graph, I need the reference line and all. So all that ideas come, but it's possible.
Okay.
Everything is possible. Right on. Okay. Then you can plot a pie chart also for a series. Getting? If you have a series, then you can draw a pie chart. If it is a data frame, then you will get multiple pie charts. Getting? So it is a feasible one for drawing pie chart for a series only. So if you have a series, then the values in that series should sum to 100. Getting? Pie chart means it is showing the contribution in the 100%. This one whole circle will be considered as 100%, and then each one's contribution in that 100%, like that. So suppose if you're having values 7, you're having 8, you're having 3, this is 12. Okay. So we will find out the percentage in the total. So first we have to take total, like 7 and 3 is 10, and this is 20, the 30. So 7 upon 30 into 100, whatever the percentage come, that much will be the contribution of first value. Then second value is 8. So 8 upon 30 into 100. So that will be the contribution of the second one. Again, 3 upon 30 into 100. That contribution third. And then the remaining will be obviously for the fourth, like that. And then this all sections in that pie, you can show with different colors. Like, okay? Okay. So this is best example, like when they show contribution of each candidate in the total votes. Like if in that constituency, the election was taken and five candidates were appearing. Five candidates appeared in that election, and the total vote was some 5 lakhs. So everyone might have got some vote from that 5 lakhs. Someone might have got 1 lakh, some 3 lakhs, some might have got 75,000. Getting? So everyone is doing some percentage contribution in the total say, total votes. So how much percentage contribution every candidate has done? That in a pie chart you can show. Getting? Or same way like for the sale also you can show. Like if you have four sales, four stores, and every store has done different sale. So in the total sale, how much contribution each store has done? Just for simplicity, what I'll do, I'll take such numbers which are total to 10 only. Total to 10 or total to 100. Like, okay? So this is 3, suppose I'm taking 2, another I'm taking 4, and 1. Getting? So if we draw a circle, then this will take 30%, right or no? This will take 20%. This will take 40%, like that. And then this will take only 1%. I was supposed to draw big, little big. Okay? So all have their contribution. So in the total contribution, one is having 30% contribution, 20%, 40%, one 10%, like that. So total it becomes as 100%. Okay? So I told you, na, like, this is candidate 1, candidate 2, candidate 3, candidate 4. 4 candidates contested the election. And the total vote, from that total vote, everyone has got some vote. So how much is the contribution of that candidate in the total votes? That if you want to show in the graph, you can show it using a pie chart. Getting? See here. So create a series. Series is a one column table where the index represents categories. That index label, if it is a one column, okay. So one column series means all these indexes are by default 0, 1, 2. But instead of that, I'll take like this. Candidate A, getting Morgan has appeared. Morgan contested the election. Second, Siley contested the election. Sneha contested the election. Garv contested the election. So these four have contested the election. So from the total vote, everyone has got some vote. No? Their contribution is there. No? 7 lakh vote, 2 lakhs vote, 5 lakhs vote, 1 lakh vote, whatever. So you want to show this in a pie chart that how much is the contribution of A in that total vote? How much is the contribution of B in the total vote? This you see in the newspaper also. No? After the elections are contested, voting is counting is done. The candidates get elected and all. So in the next day newspaper, there is a complete analysis in a graphical form, like how much BJP got, how much TVK got, how much INC got. that graph they show in a pie chart form. Same concept. So create a series where the index represents a category. Category, as I said, no, each party is a category. Each product is a category. Categorical data. Gender is a category. Age group is a category. Getting? And the values represent their respective shares. How much contribution in the total they are doing. Getting? Example C, I've created a series where I'm showing how much total sale is done by all the four companies. Getting? One XYZ person is there, he is having four companies, and he want to find out this year from my four companies how much total revenue I have done. Getting? So everyone, A has done 40 billion, 25 billion, 20 billion, 15 billion. Now, purposely, I've taken a data like this, that which is making total to 100. See here, 40, 25, 65, 85, and 1500. If you have different data, then bring it in the percentages, na, guys, to plot it properly. If you're having different data, then what you have to do, take the total and the contribution divided by total multiplied by 100. समझ रहा है ना? Like if the first value is 8, next is 5, next is 16, whatever, next is 2. So what you have to take the total and everything you have to divide 8 by the total into 100, 5 divided by total into 100, 16 divided by total into 100. So you'll get the percentage shares and that you use here for plotting. Correct? So now when you plot this pie chart, so for every company, the pie will be shown in that circle. In the circle, that one piece is called as a pie. No? Yes or no? In that whole circle, when we take that one section of that circle, this section, okay? So this one section is called as one pie. Okay, so it will show 4 pi, which makes total as 100. But every pie size will tell how much revenue you have got from each company. Getting or no? Okay. So first the series is created. Now it is up to you for what you want to create the series. Okay. I want to show the series for votes. Votes series is there. Okay. Equal to pd dot series and I'll create a list. Okay. So 45% vote X party got or 40 we will take so that the total is coming out to be okay, 20 and 50. Right? And if you want to give the label to them, then you have to give index equal to. And here I'll give the party names like that. If suppose I give BJP, then I'm giving second as INC, third I'm giving TMC. Okay. Last, suppose I'm giving NCP, whatever. If you print and see this series, okay, if you're printing this series, you'll see one column, one column table, 40, 25, and these are the labels BJP, INC, TMC, NCP. Now we are plotting, we'll be plotting a pie chart for this. Okay. So what I'll write, votes dot plot and kind equal to pi you'll give. Okay, for pie chart. See, I'll show you here. See, to plot the pie chart, whatever your series is, dot plot. Kind equal to pie chart. Okay, this you have to give. Then that percentages you want to show. Right? So this is the format you have to give. display the percentage on each slice. Okay, so dot after that dot 00 what you want. So 1.1 f in the floating point. Okay. Now to draw the pie, from which angle we have to start. So I have given start angle 90. So it will start from 90 degree. Okay. 0 degree is considered as from where it considers 0 degree. This line, the baseline is 0 degree, 90 degree, 180 degree, 270, and again 360. So it will start from 90 degree. Then for each pie, we want different color. So you can give colors equal to and create an array of color. This is the RGB combination. Huh? RGB. R is for red, green, blue. Red, green, blue. Red, green, blue. So red, green, blue combination, whatever color you get, that. Then whatever the diagram you are drawing, how much boxes by how much? So 6 by 6 I have shown. Then the title you can show. X label, Y label we don't want. It should be blank. So we have given and then plot the graph. Okay. Default, what it does is it takes that series name. Okay. Whatever that column name is there, that only it uses as Y label. So we don't want that. Therefore, we are erasing it. Okay. See. So first what we will do, votes.plot, right? Kind equal to pi. Then next thing what we need to pass, main things are there. Okay. Auto percentage PCT. Okay. The pattern is like that. Percent 1.1 F and again percent. That percent sign also should be printed. Therefore, I've given that way. Then colors you can give start angle, all the things one below another. If you want, you can keep start angle equal to I'm giving 90 degree. Then fixed size you want to give. Suppose I'm giving 6,6 tuple. I'm assigning a tuple. Then colors if you want to give. Okay. You can create an array of colors, right? I'm using the standard color like red, then blue, then yellow, okay, green. Done. Then PLT dot title you give. I'm giving votes contribution party wise, right? Then show directly, right? You can plot and see something went wrong. Kind equal to pi only. Percent two times you have to write. That is the format. So is it printing that percentage sign is also shown? Okay. And one digit after dot. And can you see here? These labels are also coming. These row labels are shown on that pie. And how much their percent, their contribution was, value, what the value is in that series. See, we printed that series here. When we printed that series, see only this much part when I executed it. Print votes. Okay. So can you check in that series, these values which are there in that series, they are coming within the pie. Okay. And their labels, what these labels were there, that are coming as a label to that each pie. This is one pie. And is it showing the contribution of each party in the total vote? So red color is for BJP. So we can say their participation is 40%. Getting? TMC got 20, NCP 15, and INC 25%. Like that. Okay? So this way you can plot it. If it is a data frame, what will happen for each series? There will be separate pie coming. If you are plotting a pie chart for a data frame, what will happen? That is for one column, one pie. So second column, you will get another pie, third pie, like that. For each series, there is a separate pie chart drawn. Okay? See, in our case, we got like this.
Start angle means what is that, sir? Start angle equal to
Here.
90.
First, this is the 90-degree start angle. We take this as a 0-degree start angle. When we take a, you're from some science background or no? Start,
Yes, yes.
so you might have done some algebra geometry both in 12th. This baseline is considered as 0-degree. This is 90-degree. So it is starting from here. See, first it start. This is 90-degree.
Okay.
Right? So from here it has started for company A, and from there all other companies. You can try giving start angle different. You'll come to know. See here, I'm giving start angle 45. Okay? So 45-degree will be here. This is 0-degree. This is 90-degree. So exactly mid will be 45. So at 45, company A will start. At 45-degree, company A. Then it's 40%. Then next company is 25. Then next like that. It will complete. Okay. See, I'm giving 45. Can you see? At 45-degree, who has started? This is 0-degree. No? This is 0-degree. Here is 0-degree. So at 45, company A has started. Company A at 45-degree. From there, it will continue its 40% contribution and then continue the other companies. Okay? You can take 0-degree also. You can try with that. If you don't give, I guess, start angle, it takes 0-degree only. 0-degree means it will start from here. This will be the baseline. See, 0-degree. And from there, it's 40% contribution, 25, 20, 15, like that. Okay? Okay, so few plotting concept I told. Now you have to explore this. You can find out if there are many more graphs, ways to plot. Scatter graph, then histogram, many other. Histogram, we have done it in NumPy. I guess that day you were absent. Morgan was absent. In NumPy, I showed you that Poisson distribution, that in random module, how that bell curve come, binomial distribution. So there we have drawn histogram. So many others, scatter graph, histogram, and all. Scatter graph generally in machine learning and all, we generally use it. Okay,
Sir,
so one part is
in crosstab format, how in crosstab format we want to display the data in that output crosstab.
pardon, I didn't understood which format.
No, crosstab table format, crosstab. The output should be in only not visually, not table format. We want to show like a crosstab data. Okay.
You want to show the data only in this way, tabular form. You can print your data frame. Data frame is printed in that form only. When you print any data frame, if you have any data frame, so the output of data frame comes in that form only. I didn't understood actually. See here, if you're printing your data frame, see here, I'm printing the data. It is showing in the tabular form only. ठीक है. Okay. Now moving ahead. Now some many more things. Now only creating a series, then creating a data frame, and then just plotting them is not only in Python, in Pandas. There are many more things. Okay, like analyzing your data frame, then finding out the cleaning of the data frame, then doing some statistical work like grouping and aggregates, and even taking the cross joins of more than one data frame. So that things also we have to discuss one by one. Okay. So first we'll see analyzing the data frame. So we have the data frame. We have already created a data frame. And if you're using this dot head method of your data frame, it will return you the top five records. Okay. By default. By default, by default, if you don't give any number, it will return the top five record. And if you give the number, only that many top records it will show. So viewing top rows using dot head. So this generally we do it after doing sorting or something. Sorting also we will learn. So if you have a data frame, then you have sorted that data frame. And from that, the top three rows you want to print, only the top three or only the top five, then use it. Okay. So what does dot head return? The top rows. Whatever number you give, that many, or if you don't give number, by default five. It is like limit in SQL. If you have learned SQL very well, so in SQL we give a limit clause, limit five. Then it gives only first five record. Exact similar sort of thing. Okay. See here, the head method returns your data frame, whatever your data frame header, along with the specified number of rows starting from the top. If you don't give the number, then by default, it returns the first five row. If you do not provide a number, head automatically defaults to first five row. Okay. So we have already created this CSV. I guess we have already uploaded this CSV, if you remember, right? Yesterday only we have done it, isn't it? We have uploaded that CSV. Or maybe like data one or data two, whichever. So that CSV, which we have uploaded, that I'm just reading it and copying it into the data frame. Read CSV will read that CSV file and put it in data frame. And then I'm calling df.head 10. It will return the first 10 rows of your data frame. And if you give only head without the parameter, it will only return the first five by default. Okay. We will do it on our data frame. First, what I'll do is I'll write the code for uploading. Okay, so for uploading, I have given you from google.colab import files. Okay, and then I'll write files.upload. I'll just call that function. I'll run this. Morgan tried that or no? Like for Google Drive and all. Yesterday I told you to try that.
No, sir, not yet. We'll
Okay, you
try.
do it now. I'll take this data2.csv. Okay. Done. It is copied. Now what we'll do is we will read it in our data frame. Okay. So data frame equal to pd dot read csv, and I'll give that file name data2.csv. Okay. If you try to print this CSV directly, sorry, this data frame directly, Is it printing? Now in the data frame, already 31 are there, which is less than 60. I told you, na, if it is beyond 60, then it will not show all. It will show first 5, last 5, in between dot dot dot. Okay? But as we are having only 31 record, which is less than 60, it is showing all. But I don't want to show all. I want only head. So see here, I'll write df dot head and give the number. Like if I give 10, it will print only the first 10. See. And if you give print df dot head with no argument, then it will print by default the first 5. Can you see in the second case, it is printing only the first 5. And you can see it is printing everything in the tabular way. Same way, there is one method called tail. As we have head, there is one method called tail, which will return the bottom records. So bottom, how many record? Whatever number you give, that many bottom record, or if you don't give the number, by default, the last 5 record. Okay. So viewing bottom rows, like sometimes in the analysis, you want to check the poor values, the best performing values. So you'll take the head, poor performance value. Then you have to go for the bottom. Getting? So who are doing very poor performance, the 5 poor performing, then go last. The best performing, then come for head. If you have sorted them already in the descending order of some value, getting or no? So tail. The tail method functions exactly like head, but it returns rows starting from the bottom, that is end. And when you don't give any number, it will give you by default the last 5 row. Okay. The same thing, what I'm doing, I'm copying the content from that CSV into my data frame. Who is reading and copying in the data frame? This read CSV. So read CSV method is reading the content from this file and adding it in the data frame. And then you are calling the tail method, df.tail. So as I haven't given any number, it is printing only 5 last rows. Okay? I'll show you. Now already it is loaded. So we don't have to load it. It is already loaded. That file is already loaded into the data frame. You can just print df.tail and suppose I'm giving 10. So it will print the last 10 recorded. Can you see from 22 to 31? And if we give print df.tail but without any argument, then last 5 will come. By default, the last 5 records. Okay? Then there is one more method of your data frame. One more method is there of your data frame, which will just give you the summary information. It's called as metadata. Metadata means data about data. So whatever data is there in your data frame, it is going to give some information about your data, like what is the class name of your data frame, the data structure, what is the data structure or the class name, then how many rows and columns are there, how much total space it is taking, getting, then how many non-null values are there in each column, as data frame is made up of multiple series, that is columns. So how many non-null values are there in each column, that count it will give. Okay, so that all thing come under one summary, which is written by info. Okay, so see here, the info method prints a concise summary of your data frame. Getting? Providing essential metadata. Metadata means data about data. So your data is already there in the data frame. In the data frame, already the data is there. So data about your data, like how many rows are there in your data, how many columns, total how much space, then how many not null value in each column, what is the class name of your data frame, all that things are printed in that summary. As we do in the SQL, in SQL we use DSC and it gives the description about your table. Exact similar thing. Okay. So the info method prints a concise summary of the data frame. See here. Now I'll just print from that file. I have loaded that data frame, that CSV file, and then I'm printing the info. Now in my case, I don't have to do that load and all, which is already done. Already we have that data frame from that file. Okay, so we will just print info directly. So print df dot info. See. So a concise summary is coming and it is telling first what is the class name of your data frame. So your data frame class name is data frame, which is in module frame, which is in a package core and which is in a package pandas. Okay. Then it is telling the row label. Row label. Initially we printed all. Remember, no? Initially I printed all. So what were the row labels? 0 to 31. So that will be the range index. Range index gives you the row label. So range index it is telling 32 entries 0 to 31. Okay. Then data column. Total how many column? 5. And each column label and how many non-null values are there in it. How many non-null values are there in it. Like here 32 non-null. Here there are 31. So if there are 32 means there is no null value because total how many entries are there? 32 entries. Here you are getting 32. Means in that column there is no null value. Here you are getting only 31. Means one value is null. Again next to 32. So no null value. Next 30 means two null values are there in that column. And each column data type is also printed. Each column label is printed. Each column label. Getting guys? And then how much memory usage it is taking. And none y came because I passed df.info to print. I passed it to print. So actually info only does the printing and info doesn't return anything. So as it doesn't return anything, it returns none. So actually we were not supposed to do like this. We were supposed to do like this. Getting? See. So everything and now none won't get printed. Because what I did, I passed that info to print. So info is only doing the printing work. So after doing printing, it doesn't return anything. So as it doesn't return anything, what it returns in Python? None. So that none was getting printed. Okay. Now this is for this data frame, but yesterday we had loaded one CSV file in which I guess 169 or something records were there. Okay, we will check that. See df equal to pd dot read CSV and we will read that data.csv. I'm sure we have uploaded this. Print df. Okay, it is giving error because it is saying file not found or something. So today we have written a code for uploading. That code only I again run. It will again ask for the file. I'll give that file. Yesterday we did this data.csv. Okay, and now you try to check this. See, now in this case, can you see it is showing only first pi record and last pi, and in between dot dot is coming. Why? Because here it is containing 169 row, and the standard setting is yesterday you remember na max underscore row equal to 999. Morgan asked me also if I make highest, what will happen? Getting? So here by default that size is 60. and your values are more than 60. Therefore, it is showing dot dot, first by, last by, dot dot. So in this case, suppose you want to show each and every record in that data frame, then what is to be used? I taught you yesterday, dot to string is to be called. Don't forget, yesterday we have learned all this thing. Okay. Now in this case, is it showing each and every record in the data frame? Yes. Okay. And now if I try to print the info of this data frame, df dot info, okay, so you'll get accordingly the information. See. So df is an object of class data frame. It is showing that. It is an object of class data frame. How many total entries are there? 16, index 0 to 168. Okay, total column 4. Then that each column label, how many non-zero are there in it? Their data types. Okay, you can check here. Can you see? Total 169, 160. No non-null is there. Sorry, no null is there. All are not null. Here also all are not null. All are not null. But in this case, 164 and total of 169. So obviously 5 values are null in this column. You can check also in this column, you will be getting 5 values which are none. See, if you find out, see 1, 2, below also few values have gone. So this is telling that total 169 but 164 non-null. Make sure 5 values are null value. Getting? And from this whole, again summary it is giving that one column is of float data type and 3 columns are of integer. And total approximate how much memory usage it is taking, 5.4 KB. Okay, so this way you can print the summary info. Like in our case, we got this. If I take this data.csv, which is containing 169 entries. Okay, I hope you got this concept. Yes or no? Just give me quick confirmation. So when you run this df.info, whenever you are running this df.info, it returns information broken into several sections. So all that sections you know now. First section is giving the class name or the data structure name. Means your data frame is kept in which data structure? So it is in data frame. This is the class name. This class is in this module. This module is in this package. Package is in this sub package. Getting? And then it is telling the row label. The row labels are automatic indexes from 0 to 168. So those 0 to 168 row labels are kept in iterable, one iterable only called range index. Then each column name, then how many non-null values are there in each column, their data types, getting? And then how much total space it is taking, everything it is giving you. Getting? So first in that info is what data structure or what the class name is. So confirms it to a Panda data frame object. It is confirming that it is an object of data frame of Pandas. Then second is range index. Remember, range index is also iterable. It's a iterable. It contains all that sequence of indexes 0 to 168. So it shows the total number of entries, in our case 169, and what are the indexes for all the entries from 0 to 168. Then it is telling the information about the columns. So total how many column? See here, it has printed total how many column? 4 column. Okay? Displays the total number of column. Then it is giving that column table. Column table contains the name of the column, then how many non-null values are there in that column, what is the data type of each column, everything is printed in that table. So list each column by index number, then the name of the column, how many non-null values are there in it, what is the data type of that column, everything is printed. Getting? And at the end, it is telling how much memory space this data frame is occupying. So estimated space, not exact, okay, estimates how much RAM the data frame is using. Getting? Okay. So I hope you got it. Now, if you want to find out that really in my data frame null values are there or no, so you can take the help of this info to find out whether there are null values or not. Getting? So if you want to find out null values or identifying missing value, okay, so you can take the help of that not null count. Okay, so using the non-null count provided by that info method, you can easily discover if your data set contains missing value. In my case, it is there in one column. See here, which column? This fourth column, which is calories column. So in calories column C, for 18th entry, for 17th entry, there is NaN. Then again for 27th entry, there is NaN. Getting? NaN means not a number. So why not a number? Because while entering, you might have kept blank. So blank cannot be treated as a number. See here, NaN. So around five places. So you don't have to do counting. From this info only, we will come to know. See here. From this info, the total entries are 169. And in all three column 169 means no problem. This all three columns don't have any null. All are not null. But in calories column, there is 164 and the total is 169. So obviously five values are sure null. Getting or blank, you can say, or missing. See here. Like in our case, in our example, we are interpreting. If the summary states range index as 169 entries, but a column like calories is showing 164 entries, okay, then use your mathematics knowledge. And from your maths knowledge, you can say that total entries are 169, not null entries are 164. So obviously in that column, there are five empty values or null values. Getting? And then these null values are, you can say, these are the candidates for the cleaning part, because you cannot keep these values. If you keep these values, your results will be not accurate. Whatever analysis later you have to do, no? You have to find mean, you have to find mode, median, then standard deviation or deviation, whatever. So if you want to find the average of that column, average calories, okay? So if in that column there are somewhere blank, so you will not get correct result, or sometimes you may get error also if you directly try to find out the average of such column. So the analysis won't go correct. So it is the cleaning responsibility, data cleaning. And data cleaning is the job of data engineer. Data engineer does that work. And data engineer makes the data uh, perfect for doing the analysis. And then that data will be further given to the data analyst, who is going to take that data and then do the statistical work, plot graphs and all. Even it is given for BI people, those who are from the business intelligence part. Okay. So if the data is null, does it matter? So yes, obviously it matters. Why? Because your results may come wrong. So empty or null value can skew conclusion. Skew means it can go far from the expected thing. What we want, it may go somewhere beyond that, or cause error also. Like if I don't remove that empty value and directly I'm trying to find the average of that column, or I'm trying to find out the mean of that, mean means average only. You're finding out the standard deviation of that column. It will give you the error only, because for finding out the average, all the values should be numeric value. Correct? So it may cause error during data analysis. So identifying them is the first step toward data cleaning. So when you want to do the data cleaning, first step is in that column, you have to identify such null value. Getting? Now, sometimes they are removed only, sometimes they are replaced with some other value. Generally, we take the mean of other value and substitute over there. Like on an average, the other values are near about like 35, 38. Getting? Then somewhere we have NAN. Okay. Somewhere we have 36, 40. So sometimes what is done, that row only is deleted, or that value is replaced by the mean of the other four. So 35, 38, 36, 40. Whatever the mean you get, that you can substitute over there to make it meaningful. Because unless and until it becomes meaningful, you cannot do the work of analysis. So data analyst and data engineer, that is the different roles are there. Correct? So data engineer's job is to collect the data from different sources, then make the data meaningful data, and then give that meaningful data to the analyst people. Getting? So different roles, that way the roles are made. Ideally, one person only can do all this. And with the help of AI, it is becoming so easy that companies will start throwing the other people, those who are just sitting with that role, if they are not making the best use of AI. Okay? So the concept is clear. So next is, what is data cleaning? That I'll tell you. And in data cleaning, what all things we'll do. And then each thing we will try to discuss in the next session. Now we'll just talk about what is data cleaning. So data cleaning means removing uh, null values or blank values, or removing inconsistent data, the data which is wrong data, okay, or improper data if you're removing. Like for example, there is a date column, and in that date column, the date is not properly enclosed in a quote, or it is not in a correct format, or somewhere there is a date column but someone has written a number only over there, or in some column numeric are there but in between there is blank left. Okay, so removing all this is called as data cleaning and making the data meaningful for the analysis. For analysis, you have to make the data meaningful. Getting? So first we'll discuss about what is data cleaning, and in data cleaning what things we do, and then each we will discuss one by one. Okay? So what is data cleaning? I told you data cleaning means fixing or removing bad data. Okay? Either we remove it or we replace it. Just now I said, in calories column, if there is none, so one person can remove that record only, or someone can replace that value with some other value. Getting? So fixing or removing bad data. Bad data means which is of no use. Keeping that data will not give you the good result. Okay, or it may give you error also, or if you it may give you the result which is going out of the expected result. What was expected, it is going far away from that because of that bad data. Correct? I'll give you that example also. Like we have maintained the pulses, and normally the pulses are from 50 to 100, 50 to 100, and someone mistakenly entered 450. So 450 entry who has done is a wrong entry. Correct? So because of that, the average pulse you are finding, it will go outlier. Outlier means you got one value is so large that your average is going somewhere beyond what was expected. Like on an average, the pulses are like, for example, 40, 50, getting near about 50 to 120. Like that, the pulses should be 77. And someone by mistake entered 450, was expected to enter 45, but entered 450. And if you keep it flat, your total data only will be skewed. The average only will go somewhere out of the expectation. Correct? So you have to either remove it or replace it. So you can replace it by the rule base or direct hard coded value. You can replace. Many rules are there. So data cleaning means fixing or removing bad data. within your data set means now it is your data frame. Data set means the data which is in rows and column form. So that data set only I'll call it as data frame to ensure accuracy. Means you want perfect results, quality, getting the data values are not wrong. Okay. And readiness. Readiness means now that data you can give it to the data analyst so that he can do the analysis on that data. He can plot graphs and he can do the summary work, statistical work and all. Getting? But to give that data to the analyst, before that the data should be ready for analysis. And that data is ready for analysis if you have done the data cleaning. Getting? So there are many things in data cleaning. We have focused the four important data cleaning aspects. So what are types of bad data? When we'll call the data as a bad data. So first one is that is empty cells. And all we have to discuss, there are four types of bad data which I'm finding. And then each one we are going to discuss one by one. Okay? First one is empty cells. Means in your table, somewhere you have left blank. Okay. So we call it as null or nan. Nan means not a number. Okay. Not a time also is there. NAT also comes. So somewhere the value is missing. The value was supposed to be entered, but you didn't enter. Or you have left it blank, that is missing, or something wrong or blank value you have entered. Okay. In your data set. That becomes the empty cell. So they have given provision. They have given provision to detect blank cell. Okay. They have given provision to drop that blank cell. All pandas has given that facility. Same like in SQL we have. SQL also we have. SQL data also is used for analysis. It's not like only pandas is there. There are many other tools which maintain the data and that we can use it for analysis. So in SQL also we maintain the data set, and that SQL data actually it is not in SQL, it is in the database management system. Only to work on that we use language SQL. Getting too many times we make misinterpretation of that. Then second is wrong format. Your data only is in wrong format. As an example, I'll take for a date column. You can take this example. Okay, now in this there is no date, but the one which I took previously, date, uh, this one, data2.csv. Okay, this if we take, is there a, here we have a date column. Can you see in those 60 values? I'll run this again. Okay, so now we have data2.csv in our data frame. So what I'll do is I'll just try to print and show you that data frame so that you come to know what are the bad data. Okay. See. So in this data frame, in the date column, somewhere there is blank value, nan. Somewhere direct a number only is entered. Can you see a big number? Okay. And somewhere the data is not quoted. It is not put in a quote. Maybe there. Or it is put in a wrong format. Okay. Okay. We will check if it is there. Somewhere it is blank. Then can you see here it is a wrong data. Okay. So wrong format. So why the format is wrong? Because the expected date format is what? This way. Year, month, day. But here someone has entered a huge numeric value. So they have given functions to convert this numeric timestamp. It will be treated like a timestamp and it will convert this timestamp to date. Getting? So that is called as a wrong format. What is expected? So inconsistent strings, numbers, or date styles. Like if it is a column, is a date column. and expected is in single quote, year slash month slash day. But someone didn't give single quote directly, someone has entered a number. Okay, so it is a wrong format, right? Then we have wrong data also. Now, wrong data example you can see here. The data is entered. The data type is also correct. The data type is also correct. The data entered is also correct, but it is not what we are expecting. This column you can see, duration column. So on average, every duration is 60 minutes, 45 minutes, 60 minutes, 45 minutes, and someone has entered 450. Getting? So it was a mistake in entry. The data type is correct. The data is also consistent. The format is correct. Format is correct means it is number only. So data type is valid, but the value is wrong for this column. Getting? So here you only have to apply the intelligence. So like typos means understand typing error, which happens. No, this is very much possible, which happens in our examination systems and all. People they do the data entry and all. So during data entry, some wrong entry can happen. Getting? And that's what because of that only that CBSC guy, that concept of OSM, on screen marking, then he fought for that only. That was the same issue. Okay, so typos meaning the entry feeded is wrong, or mathematical outliers. Outliers means you got the range is fixed. Now the duration is 45 minutes, 60 minutes, and someone entered 450. So is it going too far from the expected? Your expected was, like I'm saying, in my building, each flat average what we are finding out. Each flat, how much yearly income is there. So on an average, every flat is going from 10 lakh, 15 lakh, 10 lakh, 15, and someone is in 1 CR. So it is completely going out from the total, right or no? So to find out the average uh, annual income of each flat in the building, that's one person who is showing 1 crore, getting, will give you the wrong average. No? Actually, it is not wrong average. It is getting skewed. It is going too far from the expected standard value. Getting? So mathematical outliers or unrealistic anomaly. Anomalies means something wrong is happening. So unrealistic means how can it happen? The time where everywhere you're taking 50 minutes, 60 minutes, 45, and somewhere directly 450 minutes is wrong. Getting? Somewhere you're entering such data which can not be that data. Correct? Like in calories and all. In calories column, average calorie of that person is from 200 till 500, 200, and somewhere like directly 1,000 calories he has burned. This is actually how much calorie in that much time, how much calorie is burned by that person. So somewhere unrealistic data I have entered, like 1,000. How can it happen? That person on average is burning in that much time, this much calorie. Suddenly one day entry is 1,000. It is an unrealistic data. Getting? So it's that wrong data also we have to remove. So what all things will be done in the data cleaning? Removing empty cells, removing wrong format, okay, removing wrong data, and duplicates also. Sometimes duplicates also create problem. Getting? What average we were supposed to get, that average will change if the duplicates are there. Best example, like I take values like 2, 2, 5, 3, again 5. Okay. So if I don't take, eliminate duplicates, so I'll get what? 5 and 5, 10. 10 and 7, 17. So 17 by 5 will be taken. Okay. But if I take this unique once only, 2, 5, 7, and 3, 10. So 10 by 5, sorry, 10 by 3 only we have to take. Three unique values, not 2 is 1, This 5 is 1 and 3 is 1. So 3. So 10 by 3, you will get 3.333. And 17 by 5, 3 point something. So the answers come different. Huh? Okay. When you take duplicate and when you don't take duplicate. Getting? So sometimes uh, keeping duplicate may give you wrong analysis or not the accurate analysis. When you want perfect analysis, many times that duplicate is also to be removed. So identical rows, if there are identical rows or identical values in one column recorded more than once, then that type of records also are to be removed. Getting? So all this is the part of bad data. Empty cells is the bad data. Wrong format is the bad data. Wrong data. Getting? Means the type is right. The value is also correct. The data type is also correct, but that value is not expected. It is unrealistic value and duplicate values. Okay. So all this one by one we have to discuss. Obviously, the first part we have to discuss, that is removing empty cell. But that we will do it in the next session. Getting? So all these four things we have to learn now one by one. How to remove empty cells, how to bring the data in a correct format, how to remove wrong data, how to remove duplicates. All this thing will be done. After that, then I'll tell you how to do aggregates and all, grouping, joins. Okay, so all that in the last part we have to learn. Okay, so for today we will take a pause over here.